So this is a ridiculously hard enthalpy question. This was from, I think, 1996, and it's unlikely that you're going to find a question this difficult, but it is possible the way the new spec's going, so I thought I'd explain how to do it. So pause the video and try this yourself first. So step one is to write down this equation, so we're trying to work out this enthalpy change here. Okay, then we need to look at the different equations. So this is a type of enthalpy question where there is no formation, there is no combustion data. You're just given equations and you're expected to take these equations and sort of form it into some sort of enthalpy cycle. So the way you do that is you look at the equations and you sort of spot where they link in. So for example, if we look at equation 1, we can see that we've got ammonia and we've got oxygen. And we look on this equation, do we have ammonia and oxygen in one side? Yes, we do. So here's ammonia and oxygen. Doesn't matter, it doesn't totally balance. So you've got 5 oxygens there, 7 here. That's fine. Okay, so there's going to be a line, or this equation here. We're going to draw this equation here, but going down to here. So what are the products? Well, you see you form 4 nitrogen monoxides and 6 waters. So if you look at this equation, it's going from the ammonia and the oxygen towards the nitrogen monoxide and the water. So if you go this way, the enthalpy change is minus 909. So the arrow is going towards nitrogen monoxide. So this enthalpy change, as I said, is this enthalpy change here, minus 909. So that arrow here is minus 909. Now you might be thinking, what about those 2 extra oxygens? We've got 2 extra oxygens here. Well, they're not actually taking part in the reaction, so what we'll just do is we'll put those 2 extra oxygens down here, plus 2O2, and that would be gas. Okay, so now obviously there's got to be something connecting this equation to this equation. So we look at our reactions. We've got reaction 2, nitrogen monoxide forming oxygen. So we look, have we got nitrogen monoxide? Have we got oxygen? Yes, we do. Forming nitrogen dioxide. Right, so that's correct. So you see it's going towards the nitrogen dioxide. So the arrow is going towards here. Now if you look at this enthalpy change, this is the energy given out when 2 nitrogen monoxides bond with 1 oxygen molecule, forming 2 nitrogen dioxide molecules. But we haven't got 2, we've actually got 4. So we just take this value and double it. So it's actually minus 115 times 2, and that's the enthalpy change. So you might be thinking, what about the water? Well, we've got 6 H2Os being in the gaseous state here. We've got 6 H2Os in the gaseous state here. So there is no enthalpy change turning gaseous water into gaseous water. It's already there. So everything's being taken into account. So all we have to do to find out our answer is just do the clockwise, anti-clockwise rule. So you can see our clockwise arrows are just this one. This is the only one going clockwise. See, the other 2 are going anti-clockwise. So that gives us delta H equals minus 909 plus minus 115 times 2. And that comes out as minus 1139. It's obviously kilojoules per mole. So there we got the right answer here.